Here I'd like to introduce DISU, Dynamic Ice Slurry Unit, a next-generation cooling solution designed for high-load fluctuation industries such as dairy, juice processing, and low-temperature workshops. Unlike traditional ice water or flake ice systems, DISU produces a special dynamic ice slurry, water with fine ice crystals. It cools like ice, but flows like liquid. This means it delivers 0-degree cooling with extremely fast heat exchange efficiency. Why it matters? In conventional systems, once the load suddenly rises, for example during UHT sterilization in dairy or pasteurization in cooling, the outlet water temperature goes up, product quality drops, and energy waste increases. DISU solves this pain point by separating heat exchange and ice formation, achieving very high efficiency, keeping 0 degrees Celsius supply temperature continuously and stably, responding instantly to sudden load peaks, storing energy at night and releasing during daytime to reduce operating cost. Dairy processing. Fast cooling after sterilization is essential to protect heat-sensitive components like lactoferrin in pasteurized milk. DSU ensures truly stable 0 degrees Celsius cooling, improving product quality while reducing installed cooling capacity by up to 30%. Juice and beverage. For fruit juice, flavor and freshness depend on rapid cooling. The ice slurry's huge heat transfer area makes it 4 times faster than chilled water, helping maintain nutrition and taste. Low temperature workshops and air conditioning, DISU works as both a cooling source and energy storage system. By charging at night during off-peak electricity periods and releasing during the day, we reduce electricity bills and even the low voltage distribution capacity of the factory. Results from real projects with DISU, typical customers achieve, unlike traditional ice water or flake ice systems, DISU produces a special dynamic ice slurry, water with fine ice crystals. It cools like ice, but flows like liquid. This means it delivers 0-degree cooling with extremely fast heat exchange efficiency.